Are we still awake and alive after lunch and the session after lunch? Yeah? I want to hear you yell. I'm alive! Yes! All right, good. All right. Now all the neighbors in the area are trying to move. First, before I start off with my ranting and rambling on resiliency, I want to have applause for all the sponsors that are making this feasible and happening, because organizing a conference, I know a little bit about it, it's hellish, and they cannot do this without the sponsor, so give them a round of applause, if you please. And also for the organizers, thank you for having all the speakers here, and I hope at least I can come back a couple of times. I love Sweden too much for not being here. So thank you for being so numerous in my talk. Always nice to see so many people. I hope I don't make people go out running, screaming from this session afterwards or during. I try to behave, I promise. Failure is not an option. The reason why I choose this title is because failure is always there. And when we're building architectures and we're building any kind of system, we typically tend to forget that failure can happen. And we've seen a couple of sessions this day, some on testing, some on resiliency by Mr. Miller. So there's a couple of things here. I'm going to talk mostly on how to use Azure services for your own resiliency needs, and some design practices and things that you shouldn't be doing, things that you should be doing, and so forth and so forth. So I hope you'll learn a little bit from this, meaning that you are taking the failure out of the equation and always taking it into the equation as a real thing that can happen. Yeah? My name is Mike Martin. I'm a Belgian, and I'm sorry for that. Every single time that I'm abroad, we are in some kind of form of government forming. This time it's happening again. Last time we were without a government, it was almost 500 days. I hope this time it will take 700 days, because our country never worked as well without a government. So, and we have 9 of those, so just to know. This is where my ranting always comes from, because everything in life gets me ranting, and even the Azure part. I work for Microsoft. That doesn't mean that I don't have an opinion. Yeah, so Microsoft is in the room, I'm sorry, but I have an opinion, right? I work with ISVs, independent software vendors, and for me, their products are their bread and butter. That means that I need to make sure that they made the right design decisions. This is also one of the reasons I'm doing this. If you want to reach out to me, I got an email address which you can send mails to. I will not reply. I still have a Twitter handle, but I don't know whether that will live for long, and my LinkedIn that you can use and that you can scan on. And for that, let's get started. I have oh, you want to take a photo? Go ahead. All right. It's a little bit about back to the roots. Who have been in Azure since the beginning? In this room? 1, 2, 3 persons. Who has been in Azure for 10 years? 5 years? All right. So you all know the new bits, but you don't know the ugly bits and the old bits, right? Remember the first times that we talked about Azure, it was all about elasticity, scale, and cheaper. Yeah? We kind of tend to forget those 3 important words. Yeah? I'm going to take you back specifically with this talk, specifically on the scale and the resiliency part, which is also a part of the elasticity. If we take a look at design principles, and this is a great example of how to build a resilient application with things like Cosmos DB in the backend, because it's the one and only true global database that we can offer, because it can has a single entry point and an auto failure system behind it. Bringing these ideas back to the mainstream thinking of architecture building, that's exactly what I want to talk about. And if you're building complex systems, you need resilience to deliver reliability. And a lot of people go, yeah, but Mike, we are fully BCDR. We're good. Right. Newsflash, BCDR is not resilience, it's not reliability. It's when shit hits the fan, and it already hit the fan, so when things are too late, that's BCDR. You don't want to design for that. You want to make sure that your systems can survive. And for this, these two words are important, and that's why I put the definition on top on one of these slides. It's you want to make sure that your system is reliable, that you can kind of assure that it will be there 24/7, and resilience is how it will cope with that and how it will try to achieve that. Resiliency can be seen as, think of the Caribbean, all right, islands. What's typically on these islands? Palm trees. But what also is typically for these islands is storms, tropical storms. And if a storm is happening, the island will get touched by the storm, and all the palm trees will go flat. But once the storm hits back, the trees go up again, and they're still there. They didn't break. And this is what resiliency is about, the ability to form against the storm, making sure that we can still hold our roots and making sure that we can build our system up again once it is needed. So this is how we look at the difference between reliability and resilience. So you need one for the other to survive. Now, as I said, it's very important to know that when you're doing resiliency, it's not about the DR, because that's after the facts. That's good for when you have a Monday morning, not enough coffee, and you set all the streets of Göteborg in a certain district instead of in Göteborg Centrum, for instance. I did that once. Monday morning, I had a live database update because we were updating a product on a Monday morning, for crying out loud. Didn't have enough coffee, and I forgot to set a where statement, and I put all the streets of Belgium in Antwerp. Now, being from Antwerp, that wasn't too bad because I'm kind of chauvinistic about that city, but still, they weren't pleased. So what you need to do is restore the database. Because, yeah, you cannot, I didn't do a transaction, wrong again. So you need to do a DR, and this is for the oops momentums. Disaster recovery is good when you have an oops momentum, it's good when something totally breaks, but it's always building back up. Now, you do want to make sure that you have a high availability set there too. High availability means that you can still have load available even if one of those parts crashes. Right. Keep all these puzzle pieces together. We also have some other important words to remember, like RTO, RPO, mean time to recover, mean time to detect. These are more in an operational way that you need to look at them. I leave these for your reading. These are not important. By the way, I have a slide warning. I have a slide deck here of 187 slides. I will not go over all these slides, don't worry about it, but I will give this entire deck to give you as a little gift, as a little book to be used in your discussions, in your designs, in the things that you probably need to think over. So, let's talk about some of the things that we're doing today. So the difference between, as I explained, the difference between high availability, disaster recovery, and backup. High availability and disaster recovery could be high available because typically you have two sites or two places where you store all your stuff and you run your applications. Backup, it's totally different story. But let's take a look at this. You know that Azure is a global compute platform. We have 65 Azure regions and growing. Right? Sweden is now also a proud owner of a couple of data centers. And they're all connected by dark wire and fiber and all these things, and we manage those at scale. And a couple of years ago, we did a major design recommendation, a major design change in the way that we are building our data centers and the way that we are building our resiliency on top of that. So in the past, we had geographies that were connected, geo-replication. Nowadays, we are working more towards interconnected data centers with a low latency connection between them. We call them availability zones. And the availability zones are not only on the data center level, they are also inside of the data center itself. Because internally, all these mechanisms can move too. These are just some nice animations that you can take a look at. And all these services become available with a failover mechanism of in between 60 milliseconds if needed. So replication is happening underneath thanks to all the fibers, thanks to all the networking connections that we have and so forth and so forth. Oh. So these AZs, these availability zones, so if you ever read our documentations and we refer to an AZ, that's an availability zone. They have all interdependent cooling, they all have interdependent layers of compute, networking, so that way each of these layers can fail and scale independently. And that's one of my first main messages that I want to give. If you're designing your solutions, whether it's in a software level, whether it's in a solution level, you need to make sure that each of your layers, and it's not an ogre thing, right? For those who've seen Shrek, it's an onion. Hard, tough audience. All of these layers need to be able to fail and scale independently. There's nothing wrong with a little bit of async. There's nothing wrong with a little bit of distribution. That doesn't mean that you need to focus on true microservices. And take it from me, nobody does pure microservices, because if you want to do pure microservices and you want to design your sagas and all these things, it's a lot of work and a lot of maintenance, and typically after the fact the resiliency goes down too, because there's other things that you need to take into account. But if you can at least have different layers that are being approached by these kind of principles, you will get at a better SLA for your applications. By the way, any software builders here that are selling their products? ISVs? Nobody? Okay. Then I'm going to ask a different question. Who here promises their end users a 100% SLA? Nobody. Smart people. You do know that we as Microsoft cannot give you a 100% SLA either. You do know that, right? Why? Sorry?
It's impossible.
Yeah, why? Maintenance is one of them. But we only offer an SLA of the lowest level of 99%. If you take all the services that you're building and you're putting them together in one solution, it's all the SLAs combined. So you do SLA A by SLA B by SLA C by SLA D. So in the end, you will never reach, when you have a 99.99, let's say 4 nines, you will never have 4 nines at the end. You'll probably end up with 3 nines or even 2 nines if you have. So never ever do that. Never sell your product with a 100% SLA like I had an ISV in Belgium. Yeah, we are so resilient and we are so high available, we guarantee 100% SLA. I went like, yeah, that's a lawsuit bound to happen. Guess what? So there's that. So keep that in mind. And so if you're using these availability zones, today most of the compute and most of the things that we're offering as a service can be supported by availability zones. So that's your first takeaway. If you're designing services and you're designing solutions, keep into account that if you are doing a product or a solution that you're building and you want to have a good reach and you want a good high uptime, make sure that you take this into account as a first step. And you can still interconnect these regions and you can have some pass-through on many sites, doing replication between many things, like for instance Cosmos DB again as an example. You have region pairs that you can still set up, but you can also do replication in between. There's toolings like, let's say for instance, you can have availability for storage, but if you want to do an intermediate thing, you also have a secondary region for those things. And this is my second giveaway to you, and something that you need to take away today. And I want you to repeat after me. Don't ever take a single region dependency. You didn't get the assignment, right? I said, repeat after me. All right, I'm failing as a teacher. Don't ever, I want you to hear it, I want to hear you say it. Don't ever take single region dependency. Yeah. Why is that? We can fail too. We can do rolling upgrades, and for some reason we can block the access to a region because we are gating the deployment. Happened in the past. We don't say that it will not happen again. We're trying to do our very best to avoid it, but it can happen. but it's a safety measure. Yeah? So that also, but it doesn't only have to be this. Even though we are designing for failure our data centers, each of the zones inside of the data center have their redundant power usage, their redundant filters, their redundant networking, and so on and so on. Still something can happen to an entire region. A power down, a nuclear war, God forbid that that happens, but a flooding, not the cleaner pulling out the plug and to do the vacuum, and it's a different story. That's PCs under the desk. But you get the idea. If one of our data centers fails, our promise to you is also a failure. So you cannot guarantee your end users that your service will be up 100% or the 99% for that matter. So never take a dependency on a single region. Yeah? And then take into account toolings like Traffic Manager and Front Door, making your service available with retry policies in behind and do failovers automatically, and making sure that you have some high available services running into the secondary regions or maybe even primary regions, and making sure that you have some round robin before that. It's all these things. We have a very nice set of documentation specifically on Azure reliability and Azure availability on this AKMS link. Reason why I'm showing you this is because you can read it up on this real nitty gritty details on how these things work in the background. Yeah? I also advise you strongly to take a look at the sessions of Mark Rusinovich inside the data center. He does them every single build or every single Ignite. He has an update of that. Today is more focusing on the AI side of things. But these are still valid when you're designing systems. And speaking of Rusinovich, there's a blog where we actually openly speak about how we are advancing our own reliability and our own resiliency. There's a couple of people that I value a lot inside of Microsoft. Rusinovich is one of them, but there's also a guy named Derek Martin. He owns the resiliency options within Azure, and every single design decision that they're making, he needs to validate whether it's resilient or not, or reliable enough or not. For those who've ever been to one of the larger Microsoft conferences or been to NDC or something, you probably have seen Derek Martin. If not, look up one of his talks online. You will love the guy. He doesn't hold back. He has a ranting show, and the guy is adorable, just because he speaks up. Now, we do try to make intelligent decisions based upon data when it comes down to resiliency and reliability. And since a couple of years, we have a little project called Project, and I'm going to just go a little bit faster here, Nadia, which takes all the telemetry. It even takes into account telemetry which comes from social media. Yes, Twitter is a monitoring source that we use. It's actually funny. If you ever go to campus and you can get access to the cloud control center, because there are stores there, you can actually see a big wall of Twitter, or X, or whatever we want to call it. I don't know if it will stay valid for a long time now, because people are getting away. There's no resiliency on Twitter for the moment. Yeah, okay, bad joke again. But there's a big wall where we follow up on all the tags that are involved with Azure monitoring, because typically when there's an issue, or there used to be an issue, Twitter users were the first to know. Corey Quinn on top, because he was always ranting about AWS or Microsoft or whatever. But we did make, however, before the entire AI hype, July last year, we actually injected this inside of our data centers to do predictive monitoring and actually predict when failures would happen. So that way we could immediately get some mitigations done before something is going wrong. Is it failless? No. Is it flawless? No. But we're getting there, right? So we're trying to do a good set of mitigations and counterattacks when it comes down to these things. And we also try to diagnose immediately what the customer impact will be. You see that nowadays in new toolings inside of the Azure portal, giving you feedback or predicting there will be high loads on these data centers and so on, like in tools like Service Health, for instance. you can actually monitor those. So that's setting the scene. Now, when designing resiliency, there's a couple of pathways that we can take. Typically, everybody is moving up to the cloud on one day. And you can have either a migration path or you can have a greenfield path. That's typically the two ways that you're going. We're talking about migration. Everybody typically starts with this kind of a migration. We're running stuff on-prem. We have like an entire battalion of platoon or whatever you want to call it with VMs. We need to move them. VMware is costing us a liver, a kidney, and whatever kind of organs that you're going to spare because they changed their licensing policy. We're moving to the cloud. Forward. Good. Now, typically what happens here is everybody's doing lift and shift. Who's in these kind of projects involved? One guy, me. I'm not happy. I don't want to be here, right? Yeah. See? So, if you're doing a lift and shift, all fine, makes me happy because you're running in Azure, hopefully. Of course, there's always people that choose for AWS or GCP. Nothing wrong with that. The things that by the way, the things I'm saying here also apply somehow to AWS or GCP. But don't tell my boss that I made some commercial attempt there. So it's good. Good. So this is your typical migration path where you want to design for typically networking designing, because that's the boundaries that we have. We have all our IntelliSense on VMs and all these things. So we need to keep that in mind. Now, if we're designing for resiliency, we can at least try to design for high availability. And there's this concept of fault domains and upgrade domains. For the ones that have been in Azure since the early days, this is typical because if you had cloud services, any cloud services fans here? I know they killed them off a couple. Sorry? Yeah, okay. No, I was a fan because that was true. That was true cloud scale for me. But yeah, but you have these concept of a fault domain and an update domain. Fault domain is that each of the services can fail in a different rack and they will not impact the others. You need to design for that. And an update domain is that we will never update on the same level as in another fault domain. So that way we can try to achieve a better availability there. Yeah? Making sure that they are in different availability sets, that was the design mechanism that we had in the past, and that we actually separate concerns there. That's a little bit what it came down to. So looking at this as a resilience pattern, you have a fault domain, two fault domains, you set it up as a cluster, and that's your typical classical design that we have. So the fault domain becomes a full rack, looking at it in a nutshell. Yeah? That's a high definition of that. So availability sets made that possible, and now with the combination of availability zones, we can even put this farther apart, and the availability sets are no longer a real hard target there. So we end up like doing something like this. Or if we want to be really resilient and really high available, because we are not taking a dependency on at least somebody paid attention. If you're sleepy, I can get you some pillows if you want to. Right? So you can do anything in cloud, basically, but there's something wrong with this picture. What is it? What was wrong with that picture?
It's complicated.
Yeah, but then again, any Azure solution is. But what was really wrong with that picture? Also, yeah. Yeah. No, the real problem here is you can have availability, but you don't have the scaling part. Why? You're designing still with VMs in the backmind. You have static endpoints. This is more based upon what we have, and we predicted a certain load, and we're good with it. If you're using VMs, yeah, Mike, but there's scale sets, right? It's VM scale. Yeah, okay, try injecting them in a network while you need a high load and you need to do it fast. Well, it'll work. If you have an unpredicted load, it will kind of work, but still, The amount of work, the amount of patching is still there. You need to provide new clean images every so many times. It's still a lot of work. But the scaling part is really on the VM side. Injecting them and making sure that your software can run in distributed mode, it's really harder to do. Don't get me wrong, VM scale sets are great if you're doing batch running or high throughput HPC, for instance. But not when you're running a very agile service like a SaaS model, for instance. This is not the way that you want to approach this, because this will hurt in a management part, in a monitoring part, and specifically in a scaling part. So that's what it basically comes down to. So also the elasticity is a little bit gone here. So I told you VM scale sets, they work, and you can do them, and you can work with Windows and VMs. But if you're migrating into the cloud and you want to have a very resilient setup, keep VMs out of the equation. And now you have some smart ass saying, yeah, but what about AKS? Yeah, okay. We do the mangling and the management underneath of the scaling of the nodes, and you can scale down to 0, or can scale down to 1 if you want to, and all fine. And this is where we use the scale set mechanisms. But not every workload should be running in AKS either. And that's a takeaway. If you're migrating into cloud or migrating into something new, think twice before you're going the AKS way. Because AKS, how cool it may seem, and how scaling it can be, it comes with a very steep learning curve, and there's some false premises that we're making there when it comes down to the full manageability of it. You need to be very well skilled to make things that working there. So what you typically do if you're moving away, you're going to split up your layers because you already have them. Each of your applications, unless they're fully monolith, they run on each of the several servers that we saw in the design there. And we start off easy. Look at things like, all right, we have databases. Typically, everybody's running in some sort of MySQL server or SQL server or Postgres. Prove me wrong. Even though with Oracle, a lot of people are moving away from it because the licensing is killing them. So what do? You move away to something which is a lot cheaper, so MySQL is a good option there. So all these services today exist as a service. Use them. Don't be afraid of them. Let us do the management. Let the cloud provider do the management. And look at all the different angles that you can have your service. File shares. You don't need file shares. FTP servers. Oh yeah. Don't get me started on those. Anybody doing FTP servers here? You should know better. FTP servers are the worst security port that you can have in your solution. I'm sorry, you raised your hand, right? Yeah. Even if it has an S in front or behind it, it's still an issue because somebody can always take control of that machine, no matter what. Yeah? But take a look at how your application is existing today, and take a look maybe if you can organize yourself into a little bit of more polyglot persistence back to your storage. Because it doesn't always have to be a database. It doesn't have to be a volume. It can easily be cloud storage, of course, if your application supports it. Yeah? Just leave that for your reading. That's one of the things that you need to and there's pathways where we can help you, and you can identify a lot of things there with tooling that we offer to make it easier on you to identify the best landing zone for your database. So data is not really the issue. What the biggest issue is typically this, middleware. Typically, a lot of the things that you're writing, whether it's APIs or Windows services or whatever you have, there's always some kind of middleware that you're going to interact with, which has your business layer or your data connection layer, whatever. If it's self-written, try to host it in a function, because maybe it's not that so complex. Try to revolve it a little bit. Run it in a container if you can. And we have a plethora of choices there, whether it's a single container, even on a web API, even on a web application, an Azure web app. It can run there, smooth. Yeah? A lot of SaaS products that today we are building, some of these APIs, if there's easy APIs, we run them on app services, segregated from the rest and bypassed with API management. They just work. Right? The hardest part here is the older tech, older languages. If you're still doing that, run. I just had a nice discussion during lunch. I don't see the person here in the room. No. They were still doing VB6, even for new parts. I mean, come on, that will not scope and not scale, right? But even if you are a couple of frameworks behind or something like that, try to do immediately a big bang. Try to modernize it a little bit. You will thank me later, right? And these are the things that you need. If there's still on-premise integrations, typically you don't have any other way of like moving it into a solution like a VM. That's a given. Anybody doing BPM, BizTalk, business process management kind of things? Yeah? We're getting there closer with integration services, but still not the full monitoring part. Although we have integration services, integration environments now, we can actually do business process monitoring. So we can gradually move away from those things too. But of course, a lot of work went into these different services, so I do understand that it doesn't go over one night. So an app service, the mostly underappreciated service that we have. It's so versatile that you can use it for a lot of things. Yeah? Even running your own code, your own little engine. If you want to run Nginx, you can just run it into a container service inside of app service, and you can actually start running it, even with some background services. There's a lot of underappreciated technology behind that. Nowadays, when running like .NET natively and so, we improve the speed of the underlying information server. It's no longer real IIS. It's now running more on a Kestrel way of doing things. So things are really improving there. Yeah? Don't forget these services. They can save your life and it can save you a lot of money if you're doing it right. And the cool thing is here, it's an easy way to set up in a resilient way. Why? Because it scales now with custom scale sets, with custom scale rules. And guess what? Underneath the hood, it's something that actually comes from the Kubernetes environment. It's called Kida. We're using that now to help also scale automatically and auto-compute on these services. Yeah. A little bit on the back end, front end. If you have front ends, anything running on IIS on Apache, just move it to there. It's going to be the cheapest, the easiest way to manage, and you can have a nice and clean pipeline setup for that. For those who are not doing any kind of application lifecycle management or DevOps, whatever you want to call it, I don't care. Yeah. Start doing that. Don't wait, because this will also help with resiliency. Why? I have more slides on that later, but think about AB, think about green, blue, think about canary releases. They will help in keeping your service alive while doing upgrades. And they are becoming more and more important. Yeah. So if you're moving from on-premise, 95% of all your shit that is working today on on-premise VMs will probably work in an app service. But it's always like anything else, test, validate, work. Right? How am I doing so far? Because I think I'm halfway there somewhere. 20 minutes, yeah. Am I boring you out of hell? Am I making sense? You're making sense. Okay, good. At least somebody's validating that. Good. You can do direct code deployments. Please, like my good friend used to say, friends don't let friends right-click and publish. But if you have your source and you want to make sure that your code will probably run on an app service, this is the best way to test it. Because Visual Studio will even create your CI/CD pipeline in GitHub with an action, and you're good to go, and you can start from there. But at least it will also validate the running factor of your application. Yeah, and again, the underlying engine is IIS compatible, so you can just push it there. It's the same web deploy mechanism that we're using. So it's something that you can keep in mind. If you don't have the sources anymore, you can just scan your web service or your web app and see if it can migrate, and actually you can take the full source and copy it over to and make sure that the configuration is correct through Azure Migrate application. This is part of the Azure Migrate plan, or Azure Migrate service that we offered. It's a tool that you can download or a site that you can connect to, and this will actually do the checking for you in a secure way. We don't push anything into the public area. For those who are running today Spring apps, is anybody Java Spring? All .NET people, right? Yeah. But if you were doing that, and by the way, you can still do Spring with .NET too. Project Steel Toe, for those who have ever heard of it, it's the same mechanism. But if you are running into services that you're also running into your company and they were built by Spring, also take a look at Azure Spring apps. None of the infrastructure that you need today for running it on-prem, one single Kubernetes cluster that is being managed for you in a Spring way, and you just need to focus on the application. And it also works for .NET applications. So if you're using Steel Toe or .NET Core, you can actually run it also in Spring apps. So the name doesn't really cover the entire cargo. It's more than that. And it allows you to easily have configurations and move up to these. All right. Then there's also a set of patterns. Sorry? I thought somebody wanted to say something. Oh, by the way, if you have questions, feel free to interrupt me. The tomatoes are in the back, so you can throw them at me. Or at least he promised, so if there's none, his fault, not mine. We are also building a set of patterns that we can inject easily inside of these kind of migration factors. Yeah? And one of the things that we built is the reliable web application pattern. And we have that in two flavors, Java and .NET. And guess what? You're one of those two cores, right? You're all Java. .NET. Kidding. Yeah. Nothing wrong with that. And it looks something like this. This is a default set that we have that can be found on GitHub. But there's also an entire set of documentation on this. And we have some of these integration patterns and resilience patterns foreseen. There's an out-of-the-box circuit breaker in there. Things like this. We've foreseen these. And they're based on the 12 success factor apps. So this is a blog post from a couple of years ago from somebody who said every single web application that should have a high standard should adhere to these 12 success factors. One of them is DevOps, another one is monitoring and so on. We actually put these into patterns that we applied ourselves into the Architecture Center, and you can use them for greenfield and for migration projects. The application migration platform that we have is also using these and applying these different skills. If you want to start greenfield, you just use the accelerator that we have, and it will set up a little zone for you for a simple web application. So this is a little guidance that you have there. There's a couple of sessions built on this too. Very cute to see, and how we cope with these things from a smaller application solution which can be resilient and which can also be high available. So, and with all the best practices indeed. So keep that in mind that this exists. Now, if you want to start greenfield, the core message that I want to give there is, please, people, don't over-complexify. We're all smart people, and the thing with smart people is that their brains are mostly in overdrive, and they're thinking about all these scenarios and all these different things, and we need to do this and that and that. And before you know it, you created not a donkey, but you created a dragon. A donkey you can ride and it can be stubborn, but a dragon can like burn your face off, right? It's a little bit the same thing. So if you're doing greenfield, you need to don't over-complexify things, but you also need to keep in mind certain design aspects which will save your life at a certain point in time. Yeah? Well-architected framework as a basis. And with well-architected, I mean there's 5 pillars in there. Every cloud vendor has them. We have 5, AWS has 5, Google has 4, because they injected 2 into 1. Right. They do different math, fine by me, I don't care. But these design principles, they are written there, and I'm going to go over them in a couple of minutes. There's design patterns that you need to keep in mind. One of them that I spoke earlier is circuit breaker, transient fault, these kind of things. Make sure that you implement them on different levels. Right? And some avoidances and where failures can lie. And this is typically where we fail because we don't always see what can fail on a different level on each of the layers that we're implementing. Remember what I said earlier. Each of the layers need to be able to fail and scale independently. If you don't foresee a scalable database mechanism, that will be a bottleneck. It might be available, but the rest of the application will not be able to follow, and it will hook up the entire application, meaning that it will be less resilient and less high available. So one of the pitfalls is that if we're designing greenfield applications, we tend to go, luckily trends are changing, but we tend to go still to monolithic thinking in designing. Yeah, we need to do this service and that service, and yeah, let's build it here because we need that immediately and start injecting in software, and that's not building resilient software. But also on the layers of your infrastructure, this becomes more and more intrinsic. So you need to keep that in mind. Not everything can run or will run or should run on the same server or on the same compute layers. So the solution there is layers, and that's something I think everybody gets along with it. Even though lasagna still can end up in a spaghetti. Even if you cut it small. Don't do that with Italians, by the way. They will kill you for that. True story. Or they overcharge you for a pizza Hawaii, $100, for those who saw the viral video. But don't think you know anything. Always go with a clean slate when you're starting to design. Specifically when you're doing the latter part. Don't step into old habits and start designing from a network point of view. Why am I saying that? You need to segregate, I give you that. But there's other ways to segregate and having a hard design around your network. That's on-prem, and that was the only way that during the day people were able to protect their environments. Doesn't work that way anymore. There's other things. Think about identity. Think about throttling. Think about shielding, all these things. And a firewall will not cut it. It's also a pass-through. It's also all these other things. Yeah. So some of the things that we need to keep in mind is, of course, which I mentioned a couple of times, it's a circuit breaker. You want to make sure that each of these layers, even if they make requests, this service falls out. Well, what's going to happen? This will give a timeout. Right? What we can do here is put something intermediate in there. Think about services like Service Bus, Event Grid, integration services that can help you and take off the load from one part, making sure that they can distribute the load afterwards, but it doesn't need to be synced. It can be a sync too. If that worker cannot follow, it will pick up all the messages, but at least your front end is noticeable of a back end issue, and it can still continue. I get the message with SignalR afterwards, no problem. It doesn't always have to be sync. Of course, if you're relying on every 2 millisecond intermediate data for your services, that's a different story. Then you need to design differently. But take it from me, 80% of all the solutions that we're building don't need that. And it's okay to do slow loading of certain parts. So this is something that you need to keep in mind. So a circuit breaker then will make sure that none of the circuits that are running in front of that will fail. Making sure that they can scale and fail independently. And that's the main message that I was giving here. Right. So how do we get there? A mesh, for instance, because they do intercommunication on a name-based version. You know how everybody knows how a service mesh works? Basically, it comes down to we're putting on my least favorite sport, soccer team on the field. We all know soccer players are 11 on the field. Or there's 11 people standing on the field. They're not always playing. But if I'm taking away, name a type of player on the field. I'm bad at soccer. Sorry. Huh? A striker. Name the striker. Huh? In your national league, it will be some guy named Jan. Yeah? Good, Jan is our striker. But if I'm taking away Jan as a striker and I'm replacing somebody else there, it will still be the striker, and they all have a role to play. That's exactly what we're talking about. And this is what a service mesh will do. It will intercommunicate. And we have frameworks that work around it. And it will also give you an insight of how the team is collaborating, intercommunication skills, making sure that you have a good observability of that team. But you all know that everybody here, I still got 5 minutes apparently, so time is moving fast. You all know that everybody has a role to play, and if you take them away, it shouldn't be failing the team. And this is exactly where service meshes and active frameworks come in handy. Think about Project Orleans. Think about things like, and I'm just going to go quickly here. Yeah, that's rough. I'm not going to discuss this. Think about things like this. Istio, Linkerd, Service Fabric Mesh. Now, that's something old. I don't know whether it's still alive, yes or no. Still people who are using it, but we can forget about it. But also think about Open Service Mesh. We injected these in most of our services today. Either as a consumer, think about ACA and think about AKS, where you can actually use these and making your inter-service communication more reliable and observable. Yeah. Combine that with tooling like Dapper and Open Application Model, or OAM, you have building blocks for a more resilient and distributed way of communicating with the underlying services. You've seen sessions by Nico and by Safia and by, who else was talking? Martin on Aspired. Darn, Aspired. My mic hammer is playing tricks on me. Aspired is one of the ways of building a resilient infrastructure without having the need for infrastructure as code, for instance. Yeah? And it can play along with Dapper without having the need of a defined infrastructure. Dapper knows immediately which service can talk to another service because it's named. Right? It's these features that will make your application platform more reliable and more resilient because it can be running anywhere into a more distributed way. Yeah? Also, if you're looking at things like Kubernetes, if you are running Kubernetes, there's one thing that you should keep in mind is that your application can only scale upon the metrics that Kubernetes can give you. But what if you can make your Kubernetes application scale based on the needs that you have from your business? If you have so many thousand messages coming through, I want to make sure that I can scale on these things. This is one of the reasons why we invented Kita. Today you can have any kind of scale metric and make your application scale accordingly. If you know that there's going to be a load for, let's say, Oasis tickets. Anybody here fell into that pitfall buying $1,000 tickets? Really weird, right? But those people had to wait like 17 hours or something for getting a ticket. No, that's maybe a little bit exaggerated, but I've seen records of 6 hours waiting time. But if you can scale your application service to pick up those tickets and making sure that they can pick the availability of the services, Kita can actually help you. They know there's a queue, so we can spin up more devices, more pods, more services accordingly. And this can be based on Kafka, could be based on Service Bus, could be based on files, could be based on anything, as long as it has a certain metric or a certain kind of scale metric behind it. All right, this is how Kita works. And I've been ranting way too much. So I talked to you about Orleans. I also talked to you about Service Bus. I'm going to go and quickly jump over something that we haven't talked about, the DevOps part. So the importance of DevOps in a resilient design is that you have the automation and that you have interference without interfering and EAC. Now, why is that important? First of all, if we are talking about EAC, it allows you to bring up infrastructure fairly quickly if something fails. Remember what I said, don't take a dependency on a single region. If it does happen, and you have a single region, and you have DevOps in place, and you have EAC, you can be up and running in like 10 minutes, depending on the infrastructure that you're deploying. Is it a resilient way? No. It's BCDR, basically. But at least you don't have to rebuild it from scratch. I see too many portal click or click deploys that are happening. Even CLI is not the best way of doing it because you need to interact, you need to be worried, you need to hurry up, and things don't always work. If you're doing EAC with bicep files or Terraform or whatever you have, you actually make sure that your infrastructure stay consistent, and this allows you to have a better availability of your software too. If you then take into account that if you get some monitoring back from your system and you can say, oh, something is going to happen, let's be preemptive about it and start deploying before shit hits the fan, well, this will help you set up a little bit faster. So why do we EAC? Mostly because it's idempotent, repeatable, and testable, and it's faster to provision. That's the one thing that you need to take away. I don't have to explain you what Bicep is or what a Terraform is, although Terraform has a false premise of being a multi-platform EAC. Not because it doesn't work on multiple platforms, but because it has the same false premise than Java in the early days. Code once, run everywhere. Which is not a fact, because if you're doing Terraform, it means that you need to rewrite your entire script for another platform. Because an S3 bucket is not an Azure storage bucket, and so on and so on. But still a good approach. Right? So what it is and what it isn't, I'll leave that for your reading. But maybe something more important is the difference between DevOps and GitOps. That's also something that comes up in a more versatile way nowadays. It's not an extension of it. GitHub is actually a way of automating these deployments, making sure that they can be deployed anywhere and also roll back if needed. And typically we hook them up as a configuration file instead of a full deployment file. We're doing desired state configuration, making sure that also from a resilient point of view, this will improve your operations. Why? If some idiot gets access to your production and you start changing things, GitOps will save your ass. Why? Because the desired state will be brought back to that exact form. And guess what? That's one of the main underlying reasons for being resilient. Because the state doesn't change and the entire environment stays running. And I said this like 10 years ago. Microsoft proved me wrong at that point in time. Nowadays I'm laughing because this is really happening. Cloud enforces DevOps and there's no way around it. It's something that you should embrace and that you should talk about. So when it comes down to resiliency, DevOps can help you roll back. But also it gives you choices to be resilient. Think about A/B deployments. Think about Azure with deployment slots. Think about ACA with multiple versions, revisions. Yeah? You heard Nico talk about that in his real-life trenches program. I got 1 more minute, I think, right? Or am I going overtime already? Overtime. Oh, okay. Oh, yeah, it's 12 past. All right, I need to speed up. Sorry about that. If you're doing it in a correct way for ACA and you have revisions and they fail, the mechanism of Kubernetes will take over and it will make it back to the original version without impacting the other users that are being run at the same moment. There's a lot of more reading in this documentation, but there's one thing that I want to show you that you really need to keep in mind. It's this thing. We have a full set of resilient designs for Azure, if you're doing landing zones in an into-prison way. It's called mission critical. It's landing zones that you can deploy that can help with your own application and set them up in a true resilient mission critical environment. So if it's a business critical application, this will help you guide through a full set of operational guidance, monitoring guidance, deployment guidance, and so on and so on. It's an open source repository. You can find it at where is it? Here we are. You can find it at aka.ms/missioncritical. It's a couple of things. There's an online and a full connected one. You can even have a semi-on-premise hybrid way of working. And all the docs are there, all the deployment scripts are there, and the only thing that you need to bring is your own application. Bringing that back to another online thing. This is the Azure Architecture Service that we have, which is a part of Microsoft Learn, and this should be your go-to documentation site. And with that, I think I went over time enough. I needed to speed up because there was a lot of material. I will give you the slides somehow. I don't know how you will distribute it, but I'll leave it up to those people. Thank you for being in my rant and yelling session. I hope you enjoyed it, and I hope you will enjoy the rest of the conference. Thank you very much.